Hello and welcome back to the AI Research Roundup. I'm your host, Alex. Today is May 4th, 2025. Alright, we're diving into a paper from Hugging Face's trending list, published just 3 days ago, called DeepCritic, Deliberate Critique with Large Language Models. This research paper tackles the issue of LLMs providing superficial critiques, especially for math. It proposes a novel two-stage framework, DeepCritic, to train models for more deliberate, stepwise analysis and feedback. Alright, this first figure really highlights the difference. We see a math problem step, and below it, two critiques. The standard model's critique is very shallow. It just says, this step is correct, missing the actual error. In contrast, the DeepCritic model provides a much deeper analysis, breaking down the reasoning, performing verification, identifying why the step is flawed, and correctly judging it. This really shows that deliberate process in action. Okay, so how do they actually train a model to do this? Well, this diagram lays out their two-stage pipeline. First, there's critique teaching. They generate detailed critiques, combining an initial assessment with an in-depth analysis, and use this data for supervised fine-tuning. This teaches the model the format of deliberate critiquing. Then, stage 2, critique incentivization, uses reinforcement learning, with either human or automatically labeled data, to really sharpen that critique ability. Moving to the results, this table then details the evaluation scores across several math benchmarks, measuring critique ability with the F1 score. Alright, it compares standard LLMs used as critics, process reward models, and importantly, their own DeepCritic models. Okay, you can see the DeepCritic models, particularly the RL-tuned DEEPCRITIC 7 BRLPRM800K, achieve the highest scores, demonstrating a significant improvement over baseline models and even strong competitors like GPT-4o, validating their two-stage training approach. Building on those evaluation scores, this next table shows the practical impact of using these critiques for refinement. Okay, it measures how well the generator models, both the 7B and the larger 72B Quen models, improve their answers after receiving feedback. So, using DEEPCRITIC 7 BRL as the critic leads to higher final accuracy, and importantly, it corrects more initially wrong answers. That's the, quote, right pointing arrow C column, significantly better than using the standard instruction model for critique. So, wrapping up our look at DeepCritic, we saw that its two-stage approach, combining supervised fine-tuning and reinforcement learning, significantly boosts critique quality for math problems. Okay, this ultimately leads to better feedback that actually helps generator models correct their mistakes and improve accuracy. A very promising direction for automated, scalable oversight. That's all for today's AI Research Roundup. Thanks for tuning in.